Have you ever pondered over the significance of cellulose phosphate in our world? This fascinating compound is not just a mouthful to say, but also a treasure trove of applications that make our lives easier. Cellulose phosphate, a derivative of cellulose, is a subject that has been captivating science enthusiasts for years. Why, you ask? Well, besides being one of the most abundant organic compounds on Earth, its unique properties make it an invaluable asset in various industries. From playing a pivotal role in the medical field as a drug delivery system to being used in the food industry as a thickening agent, cellulose phosphate is indeed a marvel of nature. And the intrigue doesn't stop there. The source of this compound is another mystery on its own. Ever thought about seaweed or other marine plants being the birthplace of such a versatile compound? As we dive deeper, we will unravel the intriguing process of deriving cellulose phosphate from marine cellulose. The ocean, a vast expanse of water, is home to an intriguing treasure, marine cellulose. This treasure is not like the golden pearls we often associate with the ocean's depths. No, it's much more valuable and abundant. It's an organic compound that forms the primary structure of many marine organisms like algae and seagrasses. Marine cellulose is quite literally everywhere in our oceans. It's like the bricks and mortar of the underwater world, providing structure and support to numerous species. But that's not all. This organic compound is a powerhouse of potential, waiting to be harnessed. What makes marine cellulose so special, you ask? Well, it's all about its unique properties. Unlike its terrestrial counterpart, marine cellulose has a higher degree of polymerization. This means it has more complex structures and can form stronger, more durable materials. It's also incredibly resilient and can withstand harsh marine conditions, which makes it an ideal raw material for various applications. But there's one application in particular that has scientists and researchers around the world buzzing with excitement: the production of cellulose phosphate. Now, cellulose phosphate is a type of biopolymer. It's used in a range of industries from healthcare to environmental conservation. But producing it isn't always an easy task. It requires a raw material that's not only abundant but also resilient and flexible. And that's where marine cellulose comes in. Thanks to its unique properties, marine cellulose is perfect for producing cellulose phosphate. It's abundant, resilient, and most importantly, it's sustainable. Unlike other raw materials, using marine cellulose doesn't contribute to deforestation or habitat loss. It's a renewable resource that we can harness without harming our planet. Now that we have a better understanding of marine cellulose, we are ready to take a closer look at how cellulose phosphate is derived from it. So, how do we transform this marine cellulose into cellulose phosphate? You might be wondering. It's a fascinating process, really, and it happens in a few distinct stages. First off, the marine cellulose must be harvested. This involves selectively gathering cellulose-rich marine plants, such as certain species of algae and seaweed. These plants are then carefully cleaned and processed to remove any impurities, leaving us with a pure, concentrated form of marine cellulose. Next comes the actual conversion process. This is where things get a little more complex. The marine cellulose is treated with phosphoric acid, a strong and highly reactive compound. This treatment triggers a chemical reaction that transforms the cellulose into a new compound, cellulose phosphate. Now, if you remember your high school chemistry, you might recall that a phosphate is a molecule containing one phosphorus atom and 4 oxygen atoms. So essentially what's happening here is that the phosphoric acid is donating its phosphate groups to the cellulose, changing its structure and properties. But here's the interesting part. This reaction doesn't just happen on its own, it requires a catalyst, a substance that speeds up the reaction without being consumed itself. In this case, the catalyst is heat. By carefully controlling the temperature and pressure of the reaction, scientists can optimize the conversion process, ensuring that as much of the marine cellulose as possible is transformed into cellulose phosphate. Finally, once the reaction is complete, the cellulose phosphate is carefully purified and dried. This results in a fine white powder that can be used in a variety of applications, from medicine to manufacturing. So, there you have it. The journey from marine cellulose to cellulose phosphate. It's a multi-step process that involves a combination of biology, chemistry, and a little bit of physics. But the end result is a versatile and valuable compound that's helping to shape the future of science and technology. This transformation of marine cellulose to cellulose phosphate is indeed a fascinating process, isn't it? Now that we know how cellulose phosphate is derived, let's delve into its significance. Cellulose phosphate is not just an interesting compound, it's an influential player in several industries. Its unique properties make it a versatile tool, opening up a wide spectrum of applications. Let's start with pharmaceuticals. In the world of medicine, cellulose phosphate is used as a carrier for drugs. Think of it like a tiny delivery truck, transporting medication to the parts of the body where it's needed. Not only does this make drug delivery more efficient, but it also reduces the risk of side effects. But that's not all. Cellulose phosphate also plays a vital role in the food industry. It's used as a stabilizer and emulsifier in various food products. From keeping salad dressings mixed to maintaining the creamy texture in ice cream, cellulose phosphate is the unsung hero behind your favorite food's consistency. In the realm of biotechnology, cellulose phosphate is used for DNA purification. This is a crucial process in genetic engineering and sequencing. By binding to the DNA, cellulose phosphate makes it easier to separate from other components, facilitating the extraction and purification process. The textile industry also benefits from this versatile compound. Cellulose phosphate is used as a sizing agent, enhancing the strength and durability of fibers. This results in textiles that are more resistant to wear and tear, extending their lifespan. Lastly, in environmental science, cellulose phosphate is used in wastewater treatment. It helps to remove harmful contaminants, playing a significant role in maintaining water quality and protecting aquatic ecosystems. When we look at the vast array of applications, it's clear that cellulose phosphate is more than just a compound. It's a key player in various industries, contributing to advancements in medicine, food production, biotechnology, textiles, and environmental science. The versatility of cellulose phosphate makes it a valuable component in various industries. So, what have we learned today about cellulose phosphate and its derivation from marine cellulose? In the course of our discussion, we've peeled back the layers of this intriguing topic, revealing the mysteries and marvels of cellulose phosphate. We've delved into the depths of the ocean to the source of marine cellulose, a treasure trove of potential that lies beneath the waves. This marine cellulose is a vital starting point in the story of cellulose phosphate, a story that intertwines science, nature, and innovation. We've discovered that marine cellulose isn't just an underwater wonder, but a resource of immense value. It provides the raw material necessary for the production of cellulose phosphate, a compound that holds significant promise in a range of applications. From its role in biomedical research to its use in the food and beverage industry, cellulose phosphate is a versatile player in an array of fields. But how do we get from marine cellulose to cellulose phosphate? This is where the magic of science comes in. We've explored the transformation journey, a process that may seem complex but is fascinating in its intricacy. This journey involves various stages, each crucial in transforming marine cellulose into cellulose phosphate. It's a testament to the wonders of science and how it can harness the potential of nature. We've also delved into the role of cellulose phosphate, examining its importance in various sectors. We've seen how it's used in the biomedical field, where it's a key player in drug delivery systems and tissue engineering. We've looked at its role in the food and beverage industry, where it's used as a stabilizer and emulsifier. These applications underscore the importance of cellulose phosphate and highlight why the journey from marine cellulose to cellulose phosphate is so vital. So, where does this leave us? With a deeper understanding of cellulose phosphate and its derivation from marine cellulose. We've seen the importance of this compound, the role it plays in various sectors, and the process that transforms marine cellulose into cellulose phosphate. It's a journey of discovery, one that showcases the incredible potential of cellulose phosphate and the wonders of marine cellulose. And yet, there's still so much more to learn, more to explore. This is just the tip of the iceberg when it comes to the world of cellulose phosphate and marine cellulose. With every passing day, new discoveries are made, new applications are found, and our understanding of these remarkable substances deepens. With that, we have unraveled the fascinating world of cellulose phosphate, a world that is as intriguing as it is important. Until next time, keep exploring, keep learning.